Hello everyone, welcome to Piece of Physics. In this particular video series, we are going to start our new topic which is vectors, right? So in vectors, we will learn about how vectors are being defined. We will learn about types of vectors, how vectors can be added and subtracted. Apart from that, we will learn about how vectors are being multiplied, right? Also, apart from the theory portion, we will solve some examples based on the vector algebra, right? So first of all, question arises, what is vectors? Okay, so before the vector, we should know about scalar. Okay, so what is scalar? Scalar is the quantity having magnitude only, right? So in this kind of quantities, in such kind of quantities, we can have examples like mass, length, temperature, right? Apart from this, we can have also time is a scalar quantity. Then current is also a scalar quantity. So these are few quantities which are the scalar, right? So basically scalar is the quantity having only magnitude, right? Now what is vector? Vector is the quantity having magnitude and the directions. Okay. So what are the examples for the vectors? Okay. So example for the vectors are considered as displacement, then velocity, acceleration, force. So this is the introduction to what is scalar and what is vector, right? So now let us move to the how vectors are being represented. So now let us how to represent a vector. Okay, so in the form of symbol, if I want to describe force, so force as the symbol F. Now in this letter of the force, we will put a arrow. Arrow shows the direction. In few books, the vector sign is shown by the bold face letter. Okay, this is in the bold. Okay, if it is bold, it means the quantity will be vector, right? Similarly, I can write acceleration. So acceleration symbol is small a and it has direction which can be given by the this arrow. Okay, so these are the symbolic representation of the vector. But how to represent such vector in the form of graphical manner? Okay, so basically vector is given by the arrow. Okay, so length of this arrow is the magnitude of the this pointed arrow shows the direction. Okay, so if I increase the length of this arrow, okay, so basically the direction remains same, but its magnitude is increased. Okay, now if its direction is inverted like this, okay, so magnitude is now negative, and direction is magnitude is same, but direction is now inverted. Okay, so this is how we can represent a vector using the graphical method. Okay, now let us look into the types of vectors. So our first type of vector is parallel vector. So basically, parallel vectors are those vectors which have the same direction, right? Vectors having same directions are known as parallel vector. If I have two vectors, one vector is like this is vector A, and second vector is like this, which is vector B. Okay, both have different magnitude. Okay, so different magnitude. So both the vectors have different magnitude. That doesn't matter, but directions of these both the vectors are same. Okay, that's why such kind of vectors are known as parallel vectors. Or second kind of vectors are anti-parallel vectors. So anti-parallel vectors are those vectors which have opposite directions. Basically, the theta between them is 180 degree. If one vector points in this direction, then another vector should point in this particular direction. This is A, this is B. So here theta is 180 degree, right? So these such kind of vectors are known as anti-parallel vectors. Or third kind of vectors are equal vectors. So equal vectors are those vectors which have same direction and same magnitude, right? So such kind of vectors can be represented as okay, this is our vector A, this is our vector B. Okay, both have the same magnitude and same direction. So such kind of vectors are known as equal vectors. Our first type of vector is negative of a vector. Okay, so consider one vector which is A. If this vector is multiplied by -1, so it will point in the opposite direction. Such vector is known as -a. Okay, so here the direction is reversed, but magnitude remains same. So in the negative of a vector, generally magnitude remains same, but the direction will be inverted. Our fifth type of vector is a zero vector. Okay, this kind of vector is also known as null vector. Consider one vector A. If this is added by negative of such vector -a, so this will be a zero vector. Okay, so basically the magnitude, so basically such kind of vector has zero magnitude and undefined direction. Okay, so such kind of vectors are known as zero vector or null vector. After this kind of vector, we have one of the most important vector, which is our unit vector. So basically unit vectors are those vectors which have direction only, but magnitude of such vector is 1. Okay, so how to define such kind of vector? Okay, so unit vector can be found like first of all how we can define unit. So first of all, how we can have symbol of unit vector as, which is basically a cap. Okay, so such kind of triangle on the vector is known as cap, hat, or caret. Okay, how to find unit vector? Okay, so unit vector can be found like vector divided by its own magnitude, which is a magnitude. Okay, so this is vector, and we will divide it with the magnitude of this vector. Using this method, we can find the unit vector. Okay, so consider one vector A which has magnitude. So consider one vector A which is given by 3 cap plus 4 cap. Okay, now we have to find its unit vector. Okay, so we now, so to find the unit vector, we need to find its magnitude. So what we will do is we will do the square of both the components. So 3 square plus 4 square and their square root. Okay, so basically this will be 5 unit. Okay, so a cap can be given by 3 cap plus 4 cap divided by 5, right? So a cap can be given as, this is 0.6 I cap plus 0.8 j cap. Okay, so magnitude of this vector will be 0.6 square, 0.8 square. This is 0.36 plus 0.64. Okay, so this will be 1.00. So the magnitude of a cap will be 1. So here we can see that magnitude is 1, but it has particular one direction. Okay, so such kind of vector has magnitude unit, but it will define only direction. Okay, so what are the unit vectors for coordinate axis like x-axis, y-axis, and z-axis? So x-axis has unit vector which is known as I cap, or sometimes it is taken as x cap. Second is y-axis j cap or y cap. Third is z-axis, can be taken as k cap or z cap. Okay, so these are the unit vectors which is defined along the x-axis, y-axis, and z-axis, right? Now one new topic is multiplication of vector by a scalar. Right, so consider one vector which is a. Okay, if it is multiplied by 2, so the length of this vector will be doubled. This will be 2a. Okay, so direction will remain same. Okay, consider one another vector which is a. If it is multiplied by -2, so the length of this vector will be doubled, but in the opposite direction. Okay, so basically in the multiplication of vector by a scalar, length will be increased, and if scalar is a positive, the direction will remain same. If it is negative, direction will be inverted. Okay, now we have collinear or parallel vectors. Okay, so in collinear or parallel vectors, if both the vectors have the same direction, they are known as collinear or parallel vector. If one vector is opposite, then they are unlike or anti-parallel vectors. Okay, these are anti-parallel. These are parallel vectors. Okay, Apart from this, we have another type of vectors which are concurrent or concurrent vectors. Okay, so starting point of such vectors are them. Okay, if we have one vector like here, another is here, this is vector A, this is vector B, and third vector is here, so this is vector C. Okay, so such kind of vectors are known as concurrent vectors. Okay, so that's all for the introduction to vectors and how types of vectors are being defined. Thank you so much. Stay connected to the channel for further videos.